Wieso geht es im Gespräch über humanoide Roboter eigentlich fast immer nur um die Hardware? Genau diese Frage werden wir hier heute bei DexForce, einem der aufstrebendsten AI- und Robotik-Startups in Shenzhen, erkunden. DexForce hat mittlerweile auch den Unicorn-Status erreicht und fokussiert sich eben auf das gesamte Ökosystem. Also einerseits die Hardware, die humanoiden Roboter, aber auch das ganze Training, ja, den ganzen Software- und Application-Layer, das ganze Thema Simulation, Robotic Foundation Models. All das wird hier an einem Ort gebaut und vor allem in die reale Anwendung gebracht. Denn DexForce arbeitet schon mit zahlreichen Automotive-Konzernen hier in China, aber auch mit dem einen oder anderen, zumindest mit einem, so viel konnte ich schon erfahren, in Deutschland zusammen. Das heißt, diese Humanoiden hier und natürlich auch die Arme, die Hände, all das schauen wir uns gleich an, sind schon in realer Anwendung in der Automotive-Industrie, bei BYD, unter anderem in der Chemieindustrie, also rollen jetzt auch Stück für Stück auf den deutschen Markt. Und nach diesem Video wirst du nämlich auch wissen, ob das was für dich ist. Also wenn du schon länger planst, in Humanoide zu investieren für dein Unternehmen, ob das tatsächlich dir Zeit und Kosten sparen kann, ob die wirklich schon besser sind als ein menschlicher Mitarbeiter. Genau das werden wir uns hier bei DexForce gemeinsam anschauen.
This room here, we will demonstrate some of our embodied intelligence, how we generate all of those different skills.
So this is just for everyone to understand, because we have very many viewers that are not so technical.
Yeah.
So maybe we can explain what is this used for. So this is a 3D environment where you train like VLAs, or what is it exactly used for?
Exactly. Yeah. So if you want to try to train your real language models, especially using the simulation method, you have to rebuild your sense first, and then let the camera sensor in the simulation to capture all the data, and such as eyes camera or the wireless camera.
Yeah.
And what's more is if you can also capture some depth information. You can use a depth camera to capture the data. And yeah, and after that you will have a data set. You can all the images and your text description, and with that you have a full data set and can put it into VLA to get the action.
Ja, also das ist das Interessante, was man dort auch schon sieht. DexSim, das ist ja auch der große Vorteil bzw. USP hier von DexForce, dass sie wirklich alles aus einer Hand machen. Also das Training von Robotic Foundation Models bis hin zur letztendlichen Hardware. Und genau das sieht man dann hier wirklich mal live, wie solche Modelle dann tatsächlich auch trainiert werden. So, and this is all simulated. This is everything digital simulation, yes?
Yeah, it is. Yeah.
Ja, also da habt ihr wirklich mal einen Blick hinter die Kulissen, wie sowas dann technisch auch funktioniert. Also wie ihr solche Simulationen wirklich im Code schreibt. Und da sieht man dann letztendlich auch die Anweisungen, also wie die Umgebung aussieht, was auf dem Tisch steht und was der Roboter dann letztendlich auch machen soll.
Maybe we can generate a new environment, so you can have a foresight inside of this.
So, und jetzt wird er mal eine neue Umgebung generieren, also eine vollständig neue Trainingsumgebung in der Simulation für, ja, zum Beispiel ein nächstes Modell.
Yeah. What about we change a thing, such as the coffee carbon apple?
Okay. Can you type there every word you want, or are this limited to like coffee, apples, and?
Mostly it's tabletop things, because you operate on the tabletop.
Yeah.
You say, the 3D generation, you get two methods. First is generative. You can use the image as input or text input. You can also fetch the data set, which maybe provides a more high quality models. Is created by the 3D artist in the thing.
So, jetzt wird die neue 3D-Umgebung generiert. Wir haben jetzt ein paar Kleinigkeiten angepasst. Also vorher hat man ja eine Kaffeetasse gesehen in der Simulation. Jetzt wird eben ein Apfel hinzugefügt. Es wurden ein paar Dinge entfernt und genau das wird jetzt entsprechend neu generiert. And all these items we can see they are collected in the real world here before, or?
Oh, it's not. It's you can collect some scans, and you use a scan device to have a high quality things, or something like the industrial parts. It's hard to find the model, so you can scan it.
Okay.
Because it's a low cost and easily have it.
Okay.
At the end, you can hiring a studio artist to create that.
Okay, ja.
Never have it.
Also wenn ich es richtig verstanden habe, dann werden diese Objekte, die wir nutzen können, hier in der 3D-Umgebung, die müssen gar nicht vorher in der echten Welt collected werden, sondern werden von Grund auf eben hier generiert mit eigenen Generation Model. And what is the name of this model? Have your name like a world model, or what is exactly called?
DexIm is our in-house developed physics engine. In this branch, most of companies are using Isaac from NVIDIA or Mojico, but we developed a new physics engine.
Ja.
So, yeah.
Also ist auch interessant, ne? Er sagt, die meisten Unternehmen nutzen hier NVIDIA, Isaac beispielsweise, und sie haben hier wirklich von Grund auf eine eigene Trainingsumgebung gebaut. Ah, there is it.
Yeah, as you say, our prompt is changed. We went to Apple, and when you get the new one, so we can start to go on to execute the action. So you can collect more diversity data set. That's it. That is
Okay.
what's for you.
Ja, mega. Nice.
Thank you.
Thank you. So, und hier werden wir jetzt einen humanoiden Roboter, weil DexForce macht eben, wie gesagt, nicht nur die Software-Seite und die Trainingsumgebung, sondern eben auch reale Hardware. Und hier sehen wir eine Popcorn-Maschine vor uns. So, what can this machine do? What is the use case you are doing?
Okay, this demo showcases a complete popcorn scooping task, and from start to finish. And you can see this is the working area, and you can freely move the cup from anywhere. And you also can disturb the robot while it is reaching for the cup. Okay, let's start the inference. And we can disturb. We can see the robot can recover autonomously. And very precise.
Ja.
Yeah. And how about we take the challenge to another level? Okay. And we prepare 2 cups. One is full of popcorn, one is empty, and we can see what we will do.
Okay.
Okay, let's go. It's quite challenging for the ability about the perception ability. And the robot will move to the other side and pick the scoop up.
So, also der Roboter, der wird jetzt tatsächlich Popcorn einfüllen und werden sehen, wie gut es läuft. Aber
during the process of scooping, and our robot can be aware of the popcorn distribution, and it can decide where is the right place for scoop the popcorn. It will choose the location with the relatively larger amount of popcorn. And we use the word action model to enhance our ability to resist the disturbance from human. And which means that they can also predict the future like a human. Take human for example. If we want to get this cup, actually we can imagine what will going on in our heart, and we equip this ability to our robot.
So this is everything from you, like the world model, VLA, the hardware, everything is all DexForce, or?
Yes.
Yeah.
And we use 2 kinds of data. One type is collected from the real world, and another is generated from the simulation.
Yeah.
So we just show you some of our base technology, how we generate all those data, how we train the wall action model, how we train the simulator VLA for all those different scenarios. And then we will go to the next area, what we show our actual business.
Yeah.
And here are different kinds of industrial and cobots with our embodied brands, and also with the eyes of the robots. You can see here, this one is the sensor. It can sense the different position of the test, and also like this one. This is another type of our sensor. So it uses the system's eyes, and with our embodied brain we just showed there, we can identify how the position of the components we need to handle.
Yeah.
For example, like insert or maybe some manipulation. All of these are based on the same technologies we call the DexForce engine.
Yeah.
So our colleagues introduced it to you previously, how it generates all those data, generates the environment, the components, different components and different settings. Maybe some with some phones, with apples, with different types. But for industrial applications, we will make it more simple.
Yeah.
Yeah. It will simulate only the robots itself, the sensor, and also the environment is corresponding to the production, but nothing else.
Yeah.
It won't generate like the cats, dogs, or maybe apples, but irrelevant to the pets.
Yeah.
So it will be easier for the computing part. And also there we can see some of different types of applications. And for all those types of sensor we use, we already deploy in more than 1,000 different projects all over the world. And mainly in China, to be honest, before 2025, and now we are going globally. We start to deploy some projects in Europe and also America, and also maybe like Singapore and Southeast Asia. And with more than 50 industries, we already tried, like automobile and like chemicals and manufacturing, and some like cell phone. All of these 3C industrials.
Ja.
Yes.
Ja, also von hier aus geht es dann in alle Welt. Selbst in Europa sind diese Arme und natürlich auch die Software dahinter bereits stationiert, vor allem in der Automobilindustrie, in der Chemieindustrie. Also gerade die Bereiche, in denen Deutschland ja stark ist, bieten sich hier äußerst große Chancen. Und hier sieht man erstmals wirklich so reale Arbeit. So maybe you can explain a little bit about what is the reason for these demos here? Are they really for training the systems or this real work that you are doing here? Or what is the reason and the use cases here?
Okay, so all of these demos you see here, actually, they are from the real projects.
Yeah.
Yeah, and all of these components actually come from our customers, our clients. They send their real components or the real products here. We do the testing, and after that, we successfully deploy it in their factories. Then we bring it to here to the demo.
Ja. So, very interesting. Also hier sind wirklich reale Kundenprojekte, die hier antrainiert werden. Also keine Demos jetzt für uns vorbereitet, sondern wirklich reale Kundeneinblicke. So are you trading like one model for every client, or what are you exactly testing for your clients? Or how can one imagine what are you exactly doing?
Actually, they are using different models. To be honest, they are not one unified DLA or WAM, not like that, because it will consume a lot of computing resource. That doesn't work in the industrial. They need to high precision, the high success rate, and a very quick response to every action. Because they need to repeat the rate with maybe human, those workers. So all of this, we will train the models like this. For example, like these components, we get the 3D documents from our clients, and then we will upload it to the DexForce engine our colleague just introduced. It will generate all those data it needs by around within like 6 to 8 hours, and you will change the model, the specific model for this type. And then it will deploy in the real applications. And it works. So it doesn't need any real data in this case.
Okay. Also wirklich sehr interessant. Also wir bekommen hier wirklich die realen Kundendaten als CAD-Konstruktionsdaten und dann wird eben diese Engine genutzt, die wir vorhin gesehen haben, und all das wird dann in der Simulation antrainiert. Also wirklich Sehr interessanter Einblick hier an dieser Stelle.
Yeah, and to be honest, this kind of scenarios it requires like less, not that complex tasks. Yeah, it is the fixed environment and with some different position of the components. So we just focus on those components, how it works, how the 60 poles of the components, and we just need to tell the robot system how we can identify, how we can grab, how we can to do the manipulation. We can see here all of these are single arm, and we also have door arms like humanoid-like. And after that, we will also use it in the humanoid robots. We just show there for the pop-pump demos. This one used the grippers, not the dexterous hands. It needs to identify those boxes and then scan it from the scanner. And we would like to mention that the eyes of these humanoid robots also the same series of this kind of industrial use. And we call it the stereo camera or stereo sensors.
Okay.
Similar to the FSD technologies, we use 2 RGB, not 3D cameras for this scenario.
Okay. So are you also cooperating with I think you have also a very great automotive industry here in China. Do you profit from that also here in Shenzhen? Because you said it's the same technology, or is it all your technology? Or
Actually, it's our technologies. Yeah, it's one kind of our hardware products. It combines with the software you can see on the screen.
yeah.
We sold it to our clients with the hardware like the sensors and with the software and the models you just asked for one head.
Okay. Yeah.
Yeah.
So maybe you can explain a little bit more, why are you so focused on sim to real? Because I think that's one of the core strengths of DexForce, and I hear a lot of people talking about you need real data and real training environments. So why are you so focused on sim to real?
Actually, this is because our founder, Professor Kui Jia, he is the professor of CUHK Shenzhen, the Chinese University of Hong Kong, Shenzhen, and he started his research with the team like dozens years ago, like maybe like almost 20 years before. And he came back to mainland China in 2016 and established the lab corresponding to the Simturu and also the space sensing in another university.
Yeah.
And after that, this is the base of the basic technology of our company. And why we choose the sim-to-real but not all of the real data, it is because it is cost efficient.
Yeah.
It is the only way, currently, at least currently, it is the only way we can use in the mass production or the mass application for the industrial.
Yeah.
It cannot afford like a very long periods, like maybe 3 to 6 months. We collect the data by teleoperating the robots, and then we come to the robots, deploy the models, but it cannot reach the success rate of 99.9%.
Yeah.
It also have a very huge gap between the real robots with another one real robots. So that is why we use sim-to-real. You can generate more data with different settings, maybe with different robots, with different lights, ambient lights, with different position, the pose of the components, and with random colors and pictures on within it.
Yeah.
So it will generate the more robustness robot model comparing with the only real data.
Ja. Ja, also das ist wirklich sehr interessant und macht natürlich absolut Sinn. Aus Kostengründen sich auf Sim-to-Real zu fokussieren und natürlich auch aus Skalierungsgründen geht natürlich viel, viel mehr, als wir es ja auch schon hier gesehen haben, dass man wirklich diese riesigen Trainingsfarmen immer dafür braucht. Also ja, sehr interessanter Einblick. So, jetzt schauen wir mal, was diese Roboter schon in der Gastro können und holen uns mal gemeinsam einen Kaffee.
Yeah, maybe you need to wait a bit more.
Ja, jetzt müssen wir einen kleinen Moment warten. Er bedient gerade. Noch eine andere Kunde.
Okay, so we have 4 different flavors. One is Indonesia, one is Lajero, and Tristrito, and low caffeine. I don't know whether,
What do you recommend?
maybe in Indonesia.
Yeah. Okay.
So we can give an order through 3 different ways. One is we tap it on the tablets. The other one is using the voice.
Okay.
Another one we use the cell phone to scan the QR code and give the order by the system.
现在将咖啡将满把杯子放进咖啡机。
That was smooth.
我来关上盖子。
And actually, this is the first application scenarios of our humanoid robots.
让我们到这抛手一把，你这关于少人生老老传说。
And he is telling some stories because we are waiting the coffee machine. He scares our customer to be bored. But in Chinese version. And actually, we deploy in different Tor. I think maybe Tor recognize it has the English version in some of the scenarios, and also we have Vietnamese for the Guangxi province. And he will deliver it to you.
Okay, hier. Das sieht sehr gut aus, ja? Da ist der Kaffee. Ja, wie von Menschenhand gemacht. Nur noch besser hier mit humanoidem Begleiter. Also, ja, absoluter Wahnsinn. Und wie er vorhin auch erklärte, man kann sich den Kaffee hier einmal per Display bestellen, per Spracheingabe funktioniert es, per QR-Code. Und während wir hier gewartet haben, hat er jetzt auf Chinesisch einige Geschichten erzählt und sogar auf Vietnamesisch, weil das so einer der Hauptanwendungsfälle ist. I think he's, er sieht sogar, ja, wenn ich hier winke, ja, und kann das Ganze eben entsprechend imitieren. Also ja, tatsächlich wirklich charmant gemacht. Also sehr schön, ja. Tastes really good, ja. Schmeckt sehr gut. Ja, besonders beeindruckend hier sind natürlich auch wiederum die Hände. Und das steckt ja auch schon im Unternehmensnamen. Und das interessiert mich jetzt mal. Also wie funktioniert das? Was muss man dafür lösen? And I think DexForce is named because of the word dexterity. And I think that's very interesting. Also with this humanoid, he can grab a coffee. What would be a really challenging task, I think, a few years ago. So maybe you can explain a little bit more about the company name also, DexForce, what's in the name, and why are the hands so important also for you?
Okay, that's a very good question. For DexForce, we also use the dexterity for the dex part. And the force, we would like to hope our projects or our products can deploy in different scenarios. It has the real force to deploy and change the workflows or change the different environments of the commercial. Yes.
Yeah.
And this challenging part is door arm manipulation.
Yeah.
As you said before, you need to grab the cup and also you need to grab the capsule.
Yeah, yeah.
The capsule is very smooth and it needs to use the fingers to grab it. And it also will detect whether you capture it or not. If not, you will do it again.
Yeah.
Yeah, and until it gets it.
Yeah.
Yeah, and then you insert to the coffee machine. Yeah, and do the coffee making.
Yeah. So very interesting. Do you have maybe a little bit technical information? How many sensors one robot like this have? How many degrees of freedom has the hand?
No problem. For the sensing, we mainly use the stereo sensors in the eyes, like human car.
Okay.
And for DOF, we call it W1 Pro. We have 34 DOF for the wheel-based humanoid robots.
Ja. Ja. So, sehr interessant, ja. Also
It's empty.
da ist der nächste Kaffee auch fertig geworden, während wir gesprochen haben. Is this also used, can it be used as training data? I think it's maybe interesting for the robot also in the real environment to learn from failures also.
Of course, for our basic technology, the sim to real, actually we have the real to sim to real. So we can collect some of the failures or the real data to modify the models what we deploy in real world.
Ja, also wenn es mal nicht klappt mit dem ersten Kaffee, dann wird das wieder genutzt, eben in Real to Sim to Real. Ja? Und das ist natürlich ein elementarer Vorteil hier von humanoiden Robotern ganz grundsätzlich. Jetzt imitiert er mich, ich will ihn jetzt hier nicht ablenken. Ja, also deswegen lohnt es sich eben auch über KI und Robotik nachzudenken, um halt eben auch wirklich Mitarbeiter zu haben, die laufend on the fly aus ihren Fehlern lernen. Also hier haben wir jetzt einen KI-Schachroboter in Real Life. Tatsächlich ist es allerdings um chinesisches Schach und das werden wir uns jetzt mal anschauen, wie gut er spielen kann. So, what can this robot do here? Can you explain a little bit about chess?
You can do the Chinese play the Chinese chess with our clients or customer visitors. You commands when you do one step.
Yeah.
You commands, oh, you do a good play, good move, or oh, you play really bad. And it is showing how the embodied intelligence of the brain and also the forearm manipulation.
So I think chess is a good example also because it's a very complex task. You need really intelligence for that and not only just pick up an apple, for example.
Yes.
So maybe you can explain a little bit more about the AI intelligence in this robot. So I think he needs a very good generative model.
Yes, we use like the LLM for how it understands which is the record. This one is the horse. This one is the soldiers, and it needs to identify where the different chess locates.
Yeah.
And it needs to know the logics. And this part is conducted by the LLM parts.
Yeah.
And then for the humanoid part, it will have some action models, VLA.
Yeah.
Yeah, and you will, based on the information by the LLM, it will identify how it execute the play. You need to grab maybe the soldier to another places, and then you will react.
Yeah. So the LLM is also from DexForce. Also, you have a very open ecosystem also in China. So it's like a Quen model, for example, DeepSeek model, or
Yes. For LLM, we can cooperate with different models.
Yeah.
For example, like DeepSeek and also GPT.
Yeah.
It's okay for different kind of scenarios.
Yeah. And how good is this? Is it better than you in Chinese chess, or?
It is better than me, and also some of our European visitors play chess with him.
Yeah.
And it's very fascinating.
Yeah. Also wenn dich das hier weiterbringt und dich diese Videos hier interessieren, dann stell unbedingt sicher, ob du den Kanal hier wirklich schon abonniert hast und dem Video vor allem schon ein Like dagelassen hast. Die meisten unterschätzen, welch ein Aufwand es ist, solche Videos, Interviews und Live-Reportagen aufzunehmen. Und ein einziges Like unter diesem Video unterstützt diesen Kanal enorm. Also wenn dich das interessiert, wenn du mehr solche Einblicke bekommen möchtest, dann stell unbedingt sicher, dass du dieses Video hier einmal likest, den Kanal abonnierst und vor allem die Glocke aktivierst, um immer als erstes von den neuesten Entwicklungen im Bereich KI und Robotik zu profitieren. Und damit zurück ins Video.